I'd like to welcome everyone this afternoon. Before we begin with Curtis Garton's webinar, he'll be talking about communication patterns, identifying and recognizing patterns in everyday communication. I thought I'd spend a little time just letting you know what Oculus does. So Oculus is an information visualization company, and we deal with a wide variety of data sets or problems. Predominantly in visualization. So whether you're working in defense intelligence, finance, or GIS industries, we tend to work towards visualization solutions that work across these problems. Predominantly, we're in the defense, public safety, and law enforcement agency industries, as well as in finance. Recently, Oculus has launched analysis services. So for a lot of agencies don't have the in-house expertise in order to analyze visualization data or analyze data visually. So we've started providing these services to our customers. Along the way, we love to build partnerships and make friends. And here's a list of some of our partners and friends, notably organizations such as Esri, who make ArcGIS, and also some non-commercial organizations such as the International Network of Crisis Mappers and law enforcement organizations such as ILEA. In terms of exposure, we post a lot of our content on the web. You can find out a lot about us, whether you'd like to visit the Crisis Mappers Network and see some of our videos there, or look at our GeoTime YouTube channel. We also have off our main Oculus site a list of some of the awards we've won, specifically the VAST Awards, and our research publications. So I'd like to take a moment just to give you an idea of how Oculus likes to approach a problem. So the question we have, we often face is how do you analyze movement data? So what we're looking at here is GPS data collected from somebody, and this is quite often how a lot of analysts are looking at GPS data currently. It looks, quite honestly like dots on a map. And this tells us, this doesn't tell us as much as we can extract from this data set. At best, we get an idea of some clustering, but what's missing are things like the sequence of events or any sort of temporal patterns. So the first thing, that would be great to do is literally connect the dots, right? Give us a sense of sequence. But alone, this can be limiting. The solution, we think, is to add a timeline as the third dimension. And when we do this, you'll see time measured on the vertical axes here. We can start seeing not only the sequence of events, so as time progresses, we go up. So the most recent event is at the bottom. So we can actually start seeing this person's GPS movement patterns. We can see, what's most likely their home location, this giant column in the center, and we can see how often, more or less, they travel to other parts of the country. And all of this is put together in one visualization tool called GeoTime, which focuses on geo-temporal link analysis and visualization. And to give you some idea of the problem sets GeoTime likes to solve, we work with GPS data, crime reports data, communication patterns, and also financial transactions. And as for Oculus, that's enough about Oculus. I'd like to hand the presentation over to Curtis Garton now, who will be talking about communication patterns.
So hello again, my name is Curtis Garton. I'm the Visual Analytics Product Manager. Today we're going to be talking about communication pattern analysis. We put this presentation together a little while ago after we had a number of individuals we were working with that were interested in getting more into analyzing communication data. So understanding what are some of the things that we can learn from data that's really all around us, data that's sometimes public data that we can grab off the web. Sometimes it's our own personal data that we have access to. And so we put together this kind of overview just to highlight some of the opportunities out there for communication analysis. It's by no means an exhaustive overview. it's really kind of our perspective on communication analysis of everyday communication. So what are some of the goals of communication analysis? What are some of the things that we're trying to learn through the communication events that occur on a daily basis, on an hourly basis? Pretty much every second of every day, there's billions of communication events that are occurring. So one of the things that people like to use communication data for is to understand social hierarchies. How is a group structured? How is a number of individuals related? And this can be shown through the communications that occur between these individuals. Looking for individuals or parties of interest. So which one of these individuals gets communicated with the most? Which one of these groups communicates or broadcasts the most? These are things that can reveal a lot of information and intelligence about groups or individuals. And so definitely looking for parties of interest is one of the areas that the communication data can definitely be utilized. Looking at things that happen before and after an event. So the lead up to the Super Bowl, there's obviously quite a lot of communication activity that occurs leading up to that activity, and then after that activity with a number of communication events that would occur after that. And so the lead up and post-event communications can definitely reveal a lot about an event, what parties were involved in the event, and then what takes place afterward. Finally, looking at locations of interest. So, why does this individual communicate to these 5 people only when he's at this part of town? That's a very interesting pattern, and it's something that can help us identify what these locations have, what meaning some of these locations have. So identifying places, locations, areas of interest is another goal of communication analysis, and something that we can learn for. And we'll take a look at that coming up here. Different types of communication data. So one very, very common type that we use every day, and pretty much every one of us, I'm sure, is doing some form of this today, is called asynchronous messaging. And this is really a message that is sent from one individual to another, but does not require an active link or an active communication. So SMS is a great example of this. You send someone a text message, they will pick it up when they're next at their phone. Email. You send your boss an email, he's going to get it the next time that he checks his email, whether that's in the morning or perhaps when he's back in the office. Tweets are another example of this. You can send a tweet directly to an individual, and they will pick that up once they've checked their account. Synchronous or bidirectional communication. This is an active connection. So a telephone call is a great example of this. You have 2 individuals who are actively communicating. It requires this real-time connection between the 2. And so examples of that, obviously telephone calls, Skype calls, anything that's really active or requires a real-time connection between 2 individuals. Broadcast communications are a really interesting one. These are one-to-any. And so anyone can really pick up on the broadcast or the signal. So obviously radio is a great example of that, but also blogs and news feeds. Anybody can go and grab a BBC's RSS feed and pick up on that. So that's a broadcast communication that's taking place. And finally, group messaging. So this is one-to-many, but the many are specified. So they are all part of a group that's been defined. An example of this would be interrelay chat, or IRC, which has the notion of groups where you can communicate with the channel. Different data types. So we have the different forms of communication that can take place. But what are the underlying data types? What are the things that we are going to use for analysis? What are the things that we need to go get in order for us to perform analysis? So examples of this would be telephone call records, email logs, social network messages. So this could be anything from a Twitter feed, Facebook posts, IM logs, so instant messaging logs from a number of different services out there that do instant messaging, network traffic logs, radio communication logs, even transcripts. can be used as a form of communication data for us to perform analysis. So like I said at the beginning, a lot of these different data types are readily available to us and are involved in pretty much everyday communication that we do today, and so we can most likely access a large variety of these data types already, which would allow us to do analysis. So digging into the data, let's look at the anatomy of a basic communication event. So what's at the atomic level? What does this data represent? How is it represented? What is one communication event? So in the context of what we're going to be looking at, it's going to be defined as a source for the communication event, which has a location, and that message is going to be sent to a receiver that also has a location. And we can have a start time or a send time, and then potentially, not always, we can have an end time. So if you're looking at a telephone call, well, there's going to be a duration. So you're going to have a start time and an end time. If you're looking at, let's say, BlackBerry Instant Messenger, you're going to have a sent time, and you're also going to have a received time, so the time when the message was actually received by the other party. So if we look at the examples at the bottom there, we have 3 examples: phone call, email, and Twitter. This is typically how the data is going to be defined. So phone call, you're going to have a source. So we got John, the date and time of the call, the end time, and then the receiver, Sally there, and the call came from John at location A, and it was received at location B. Email, obviously we don't have a location on that, so it's going to be just John's source email address, date and time again, and then the receiver, Sally's email address. Twitter, pretty much the same thing, and we can pretty much extrapolate from there how the other different types of communication services would have their data represented. So what we're really looking for is to have a source and a destination there, and then a time. Those kind of the key elements to that. Obviously having a location adds the ability for us to do location-based analysis, which can augment what we're doing. But at the base level, we absolutely need to have a source and destination with a time. So for the scope of the analysis work that we're looking at, as I said, this is going to be a message that's sent from a source entity to a destination entity, and we're looking for location information. It can be geospatial or network-centric, so it does not have to be a place on the globe. It could be part of for example, someone is part of an organization. So where are they in the organizational chart? And we can do analysis that way. So we're gonna look at a number of different patterns that we can identify in communication data. We're going to look for frequency of communications, the locations in which the communications occurred. We're going to do a time-based analysis on the communication data, and then we're going to look for some pre- and post-event behaviors. Finally, we're going to wrap up with looking at social network data. And so this data is typically network-centric, not geospatial-centric. And we'll take a look at a number of tweets that were collected as well as Facebook posts. So the first one we're going to take a look at is call pattern frequency. So what these are essentially phone calls that have taken place, and this is the underlying data. Now, some of the things that we're going to look for when we're looking at things like phone calls, could be Skype calls, could be, again, any communication source that we're looking at. It's going to be things like who makes the most calls to other parties. So who is the individual that we're interested in? Who are they calling the most? And then inversely, who's calling them the most? And so we can identify top 3, top 5, the top contacts that are communicating with the individual that we're interested in. And so what we've done here is we've gone ahead and we've found the top 3 contacts. We've also color-coded our data set. So this is a really important part of visual analysis, is the ability to understand data just by looking at it. And so one of the things that helps us there is if we can understand based on the color who communicates the most with this individual and who communicates the least with the individual. So based on the number of calls that they've made to this individual, we've colored them from red all the way through to green, which is the least amount of calls to an individual. So now we can understand, again, who's a common contact that gets communicated with, and who's someone that very rarely gets communicated with. We can also look for the frequency of these events. So let's say there's a number of rapid phone calls, one after the other, that take place. Those are visually shown. So here you can see I've just highlighted activity bursts that have taken place. And so we have these periods of relative calm where there's very few calls that are placed, and then we have these activity bursts. And so based on the timing of those, there may be something interesting there that we want to dig into. So these activity bursts are definitely patterns that we look for to identify activities and events that are either about to take place or are happening after an event. So here's just looking a little bit closer at the data. We can see that we can map again the color of these calls based on the frequency of calls there. So again, the more that an individual is contacted, the more red they will appear, and that allows us to quickly identify who's a common contact and who's an infrequent contact within the data. Location patterns. So location patterns are really interesting. The reason that they're interesting is that it can definitely reveal a lot about intent, purpose, and other aspects of why an individual is at certain locations. Here we're going to be looking for things such as individual tends to communicate only with a certain group in certain locations. And or let's say the frequency of communications changes based on their location. And so we want to identify what these locations are and where the communication events, the frequencies change based on the location. So here's two examples. We have the example in the top left. I guess it's more middle left, which is that yellow circle is a location, and then in the center bottom there, you can see there's kind of a red or orange colored circle. So those are two different locations, and if we look just above those, you can see the pole going up there. Those dots represent communication events. So if we look at the top left-hand corner, we're going to see that there's a number of calls that are placed to green individuals, and as we saw before, green means that they're infrequently contacted. So when this individual is close to that yellow circle, they're calling infrequently contacted or infrequent contacts. Down here, when they're in that orange circle, you can see that they have calls with the most common contacts. So this could be family members as an example. So perhaps the yellow circle represents home, and that's why they're not calling family members, because they are at home. And orange represents a friend's house. And so when they go to their friend's house, that's when they're going to be calling their family members the most, and thus we see the orange lines because the family members are the most contacted. So there's a ton of stuff that we can learn just based on the frequency of calls depending on location. We can also find locations that have, let's say, higher frequency or lower frequencies, which would show us different aspects of what that location is. Communication timing or times of communication. So here we're going to look for just look at when the volume of communication changes based on the time of day. So instead of looking at, let's say, the frequency of it, we're going to look at the communication events based on what time it is in the day. And through this, we can identify things like when are the hours that this individual is most likely resting. And so here you can see we've got these long periods of no communication events that have occurred there on the graph, and the graph's just showing us the volume of communication. So the higher the bars, the more communication events that occurred. And here we can see peak activity. So this could be Facebook posts from a profile, and we can identify when this individual is most likely away from their computer resting, and when they are in a position where they can post on Facebook. And we can see that they they commonly tend to post between 3 and 6 o'clock there. That's their peak hours of posting. If we want to extrapolate this out or look at a larger data set, here we can see what we like to call life patterns. And so life patterns are essentially patterns within communications or movement that reveal kind of the daily grind, I guess you could say, the Monday through Friday pattern that most of us tend to have. And you can see by looking at that the graph again on the left-hand side, we can see these communications communication events that occur roughly at the same intervals and at the same volumes. And so this is going to allow us to identify the normal routine of an individual, and then be able to look at exceptions and outliers. So once you've identified the normal pattern, this is going to allow you to look at differences in that pattern. So when is it not the same communication patterns? Where were they? What were they doing that caused the pattern to change? And that's really interesting when you find these changes in the normal day-to-day life cycle. So here we have the resting hours again, pointed out on the right-hand side there. So let's kind of shift gears a little bit. We're going to look at kind of more social network data. What does social network data mean? This could be anything from tweets to Facebook wall posts, check-ins on Foursquare. Really, we're just trying to put that big umbrella of social media out there. It can really be any type of event that, again, has a sender, an originator for the message, a receiver, and a time. The graphic, the screenshot that we have there is tweets that we're all using a common hashtag, and basically we just loaded those into Excel, and here you can see the different columns. We've got the name and then name 2, so we've got name, which is the originator, name 2 is the sender, the time that they sent it, the date that they sent it, and then the actual status update there. And so what does that look like if we wanted to put it into an interesting visualization? So on the left-hand side, we've got the network graph of individuals who, or I guess Twitter accounts that have communicated with each other, as well as to the hashtag. So EdCampTO, which is that large gray circle there with the arrow pointing to it. So first thing we can see right away by looking at this network graph is that we actually have a core group of individuals who are communicating together. And so these are individuals that are communicating the most together, and they have a number of followers who are also interested in what they're communicating with, and those are kind of the people on the fringes there. If we look in the center, we can see that there is an event that occurs. So if you look at the overall tweets, this graph shows us that there's a build-up. Just after 8 o'clock, it goes till about 9. It starts falling down rapidly, and then between 9 and 10, there was, in this case, it was a presentation that occurred. So we really wanted to figure out what had happened there, so we went and dug into that. And this was a conference that occurred, and so what we read into that is the histogram. That graph shows us that people were messaging excitedly about the presentation that was about to come up, and then as the presentation starts, very short presentation, but as it starts, you can see the traffic falls off, everyone's listening intently, and then as the presentation kind of wraps up, boom, people are back on Twitter to talk about it. So this is that pre and post event activity that I talked a little bit about earlier on, and it's pretty clear to see there that something happened. People were excited before, and then they wanted to discuss after. On the far right-hand side, this is just a temporal view, so looking at those tweets over time, so we can kind of see that event or that activity that occurs right in the middle there, and so this allows us to see that in a more detailed level. Facebook posts, so these are posts between a number of Facebook profiles. This is again the network graph. Really difficult to get much out of there. If I zoom in on a portion of it, just to let you guys kind of understand what you're looking at. So the lines represent posts, and so those are events that connect individuals. So if I go post on your wall, that's going to connect me to you, and the nodes there, the little icon of an individual, that's obviously the profile that we're representing there. And so looking at this, obviously Facebook, people are very, very interconnected. We are looking for little clusters of activity such as this, and so this is kind of a blow-up view of part of that network. And what we're looking at here is a Facebook profile that has lots of activity from individuals around it. So you can see those fringe profiles. And so these are all other profiles that are posting onto this one individual's wall. And what's interesting about it is that we can also represent the volume of communication or posts that occur there based on the line thickness. So what this helps us do is it helps us look for who are the individuals who are communicating the most or posting the most in this case with that profile on that wall, and allows us to dig deeper into that. So just by looking at this, you can see that there's about 3 or 4 other profiles that have a lot of traffic between the one in the middle there, and so we'd most likely want to dig into these other profiles to see if there's anything we can learn from them, how are they connected to that individual, and what kind of sequence or order do they have in the communication event. So what we did is we brought that same network. So you can see we've got the maroon individual or profile in the middle there. Same thing that's here, but now we've added the element of time. So the newest posts are down at the bottom, the oldest posts are up at the top, and we can see that again we have this period of activity, and then we have a resting period right in the middle there where we have no activity, and then it starts up again. On the right-hand side, you can see that leaf branch. So this is an individual that's not very well connected within that group, but that they have a link there. So the guy in red, he's obviously linked, but he does his post after he's communicated with the individual on the far right in dark green there. And so that's interesting to us. Why was he, or how is he, I should say, connected with the rest of that group? And obviously the most active profile down there is the one in maroon. So to wrap up, just to kind of summarize some of the stuff that we've been going over, time, location, and connections really play a critical role in communication analysis. All those different aspects really help us understand what an individual is doing, what a group's been doing, what are other things of interest that we now want to go look at. Communication data typically contains patterns. It's all about how you analyze it, how you look at it. We want to find those patterns really quickly, because they can help us understand, again, what's the norm, what are things that we're used to looking at, so we can find the exceptions. And once we've identified the norm, it's very simple to spot those exceptions. They really pop out. And that's it from our end. I'd like to thank everybody for joining us today. I'm going to hand it back to Adil, and thank you, everyone.
All right. We're going to move to a Q&A portion right now. If you have any questions, please feel free to type them in the chat on the side, and what I'll do is I'll read them out to Curtis. So Curtis, first question: where are you getting your data for Twitter and Facebook analysis?
So there's a number of ways you can do this. The most basic is to essentially go and search on a hashtag. For example, the Twitter data that you saw there in Excel was something I just did as a side project. So I went and just used the Twitter search function, and I searched for that hashtag, and I pulled the tweets down manually. There are a number of both open source and commercial tools that can help you with this type of data, and so not just Twitter, but a lot of other social networks. And again, they can range from a free open source project all the way through to $500,000 commercial tools and services that will help you to essentially harvest or get access to this data. Now, just to make sure everyone understands, there is no way to go in and pull private posts from Facebook. Essentially, all these tools do is just a more programmatic way to pull down public data. But again, you can do this manually if you so choose. If you're more technically inclined, there's a lot of tutorials out there to help you to write like Perl scripts or a Python script to do this in a more automated fashion. But like I said, the Twitter data that I just talked about, that was something that we just manually pulled down ourselves.
All right, we have time for a few more questions. There's another follow-up question about data. For phone analysis, where are you getting your data?
So the data that we were actually using here were actually volunteers from our company. So they volunteered to have their phone records typed up into Excel. Actually, I think we just drag and drop them from their online account, and we were able to just bring that into Excel again, and then bring that in there. Otherwise, in the law enforcement context, you obviously have to go through the procedures there through a legal request to get access to phone records. I'm just going to throw in one more thing just to kind of bring this back into the general communication type discussion, phone records was just a simple one for us to look at, but things like Skype calls, Google Voice, they all keep a very detailed log that you have access to as a user. So you can grab your logs from any of those voice over IP applications and bring those in for analysis. So, like I said at the beginning of the talk, there's lots of this data that's out there that we don't even realize that we can be looking at for different analytical purposes, whether that's for personal, for research work, or other.
And we have clarification. So to clarify, you can consume phone company data, i.e. phone toll records.
Absolutely, and so the way that the data is represented again is in very simple in a very simple way. So most phone data that's out there is obviously going to be the originator of the call, the person who gets the call, the time of the call, and then the location of that. And so that's a very simple way to represent the data, and it's not that complex when you break it down into the atomic level of what is a communication event. It's someone sending a message to someone else at a certain time, and that's what we really try to focus on is looking at the basic atomic level event so that we can connect them together with other events so we can show these patterns.
And do you include animation in your visualization analysis to represent time/4D?
Absolutely. We typically don't show them in these presentations just to keep things really simple. But one of the most effective ways I find that you would want to look at this data, especially communication data, is going to be to have an animated playback. What that will do is it allow you to visually watch communication events take place. And what that helps our team with when we're doing analysis is looking for those bursts of activity. So when you play that back in real time, you can see those bursts happen, and that we find is really helpful.
And if you're looking for some examples of that, if you look under our links worth visiting, there's the official GeoTime YouTube channel, and some of those will have videos of what the animation sequences look like in GeoTime. All right. I think if there aren't any more questions, we'll wrap up here. Just a reminder, we have a link to a survey. It'll take you about 1 minute to fill out, and just give us up. And please feel free to be honest. We use this feedback to improve future webinars. So just click on the link, fill it out, and we'll be glad to look that over. And I think with that, we're gonna end the session. Thank you again, all of you, for joining us, and thanks for Curtis for the great presentation. We'll be holding future webinars, and don't forget to check out the webinar schedule also listed on the GeoTime website. Take care and have a good afternoon.